In this lesson, I'll show you how to solve limiting reactant and theoretical yield problems. This is question number 4. The question reads, the following reaction is used to obtain iron from iron ore, and that reaction is shown underneath. The reaction of 167 grams of ferric oxide with 85.8 grams of carbon monoxide produces 72.3 grams of iron. Determine the limiting reactant, theoretical yield, and percentage yield. So we have to do 3 things in this example. We need to find the limiting reactant first, from there find the theoretical yield, because we have the actual yield, it's right here. And then we need to find the percentage yield. Starting with the limiting reactant, what I want to do is write down all the information that they've given me underneath this balanced chemical reaction. So we're told that 167 grams is produced of ferric oxide, so I'll write that underneath, 85.8 underneath here, and 72.3 right here. Let's go ahead and do that. We have the mass of ferric oxide, the mass of carbon monoxide, which is 85.8 grams, and the mass of iron, pure iron, is 72.3 grams. Next, what I want to do is find the molar mass of each of these compounds. And I'll represent molar mass by the capital letter M. And to find the molar mass, we need to look up individual atoms found in each of these compounds within the periodic table. And if you do that, you should end up finding these numbers. So our first compound was Fe2O3. To find its molar mass, the molar mass of iron is 55.84. And we'll multiply that by 2 because there are 2 within this compound, plus 16.00 times 3 oxygens. The same thing will be done for carbon monoxide. Carbon monoxide, we have 1 carbon, which is 12.01, plus 1 oxygen, which is 16. And for pure iron, it's easy. It's 55.84, so I'll write that down. 55.84 grams per mole. I'm going to use my calculator to sum these numbers up. We have 55.84 times 2 plus 16 times 3, and this gives us a total of 159.68. 159.68 grams per mole, and I will write that here as well. Similarly, I'll take 12.01 and add it to 16. I don't need my calculator for that. I should end up with 28.01 grams per mole. Now, to find the limiting reactant, we need to first find the number of moles for each of these compounds. So starting with Fe2O3, I'll represent the number of moles by the letter N. And what I'll do is multiply 167 by the flipped or reciprocal version of this rate. The molar mass is considered a rate. We have one unit over another. So I'll take 167 grams and multiply it by 1 mole over 159.68. Notice the difference between the way this is written and the way this is written. Here, the gram units will cancel out, leaving us only with moles. Using my calculator, 167 divided by 159.68 gives us 1.045. 1.045. Notice that I've recorded 4 significant figures here, although each of the numbers we start with has 3. So our final answer at the very end should also have 3. But I'm keeping this extra 5 just to prevent any sort of rounding errors. Now we need to find the number of moles of carbon monoxide. And then from there we can decide what is the limiting reactant. Once again, I'll take 85.8 and divide it by this number. We have 85.8 divided by 28.01, and this gives us 3.063. Now that we found the moles, we can go on to decide what the limiting reactant is. And we do that by setting up 2 ratios. One ratio will compare the amount of moles of this to this, and notice that we have a 1 in front and a 2 here, so it's a 1 to 2 ratio. And I'll write down the number of moles right underneath this 1.045, because this column represents Fe2O3. Another one of my ratios will compare carbon monoxide to iron, and it's a 2:2 ratio, or in other words, 1:1 ratio. And I'll write down 3.063 underneath here. And what I'm looking for, since this is a ratio, is the equivalent of iron in both of them. Now to find x here, I'll multiply 1.045 by 2, and then that gives me my x. I'm cross-multiplying. 1.045 times 2, and that gives me an x value of 2.09. 2.09. The number that is the smaller of the two is the limiting reactant. So if I multiply 3.063 by 1, and then cross-multiply with the x and the 1, I should end up with an x value here of 3.063, and that's expected because it's a 1:1 ratio. Now notice that this is our limiting reactant because it is smaller than 3.063. This compound is our limiting reactant, and we'll use the number of moles that we found here to show the number of moles of iron. So to represent the number of moles, I'll write down N is equal to 2.09 moles. We now have everything we need to find the theoretical yield. To find the theoretical yield, I'll multiply this number with this number. And there's a reason why I'm doing this. I take 55.84, and that's grams per mole. And if I multiply that by 2.09 moles, the mole units will cancel out, leaving us only with grams. Let's use our calculator. Times 2.09, and that gives us 116.7. Mass of 116.7 grams. We found the theoretical yield. We know the actual. We can now find the percent yield by taking the actual divided by the theoretical and then multiplying by 100. I'll show my work over here. So I have 72.3 divided by 116.7 times 100%. You have 72.3 divided by 116.7. Multiply this by 100%, and this gives us 61.95. But remember, we need three significant figures. Because this 9 is odd and it's followed by a 5, this 9 will go up by 0.1, and this number becomes 62.0% yield. And there you have it. That is how to solve limiting reactant and theoretical yield type problems.